looking here at the core practical on neutralisation, and this core practical is all about using a solid base to figure out the exact mass of that solid base that will neutralise the acid. And in the process, you can then use some calculations on concentration that you'll look at in another video to figure out the concentration of the acid. Okay, very similar to a titration. The only difference is that with a titration, the base is not a solid, it's a solution, and there's a slightly different method that will be in another video. Now, to do this, I'm going to show you a website. Now, I'll also show you how to use it. The password and the username are on the classroom. However, once you go on it, it's Focus e-learning. You go on the required chemistry practicals. We are covering the Excel spec, and this one is investigating neutralisation. Now, it's a really straightforward practical. I've got a beaker with some acid in, and at the bottom I've got my calcium hydroxide base, and then I've got some indicator paper. So all you do is you add it in, you stir it, make sure it's all reacted. The way you know it's all reacted is it will go colourless, because what you'll be producing here is, if this is hydrochloric acid, you'll be producing calcium chloride, which is soluble, and water. And then you'll test it by dabbing it on some indicator paper, and there you go, that's red, and so it's about pH 2. Okay, you then add some more in, give it a stir, test, it stays red, add some more in, give it a stir, and it goes sort of an orangey colour. Now, it's a very frustrating, I'm going to keep going and I'll talk over it. It's a very frustrating practical to do in the lab, because it doesn't actually happen this quickly. It takes 5 or 6 of these to actually even change it from a dark red colour. The reason is, and you'll see why in a second, it has something called a titration curve. So there you've got about pH 10. Keep going. Keep adding it in and keep testing, and it will stay up there at pH. That's roughly about pH 12. All right, now quite often there is a question in these exams which is, how would you improve the method? The easiest way to get a mark when they ask this is to use a digital reader. So in the case of this, we are going to use a digital pH meter. You could use a digital thermometer. It gives you a more accurate result. Okay, as you add in, you then test it. So you'd have a probe, and it will give you the exact pH of that solution, and this way you get a more accurate reading. So that's only gone up by, the pH has only gone up a small amount there, 0.1, just over 0.1, just under 0.2, again just under 0.2, and you keep adding it, and then all of a sudden it shoots up. So that's 0.3, 0.6, 0.9, 1.2 grams neutralizes perfectly the acid. And then you'll see that it goes straight up to 10. Give it a stir, and it stays sort of roughly about 10. At this point, what you find when we do the practical is it actually doesn't go colourless, it doesn't all dissolve. That's because the calcium hydroxide has no more hydrogen in acid to react with. So there is hydrogen that's reacting with the OH2, which is giving you the water, leaving the soluble salt, the calcium chloride, behind if we're using hydrochloric acid. Once all the hydrogen in the hydrochloric acid is reacted, you have just got water, calcium chloride, and then you're just adding more calcium hydroxide, and it's not doing anything. Okay, it stays up there at about 10. That's because it's not particularly soluble, so you will see some precipitate there. What this means in terms of the graphing and the analysis side of things is that you'll have to do a titration curve, and titration curves are very, very straightforward. Up your x-axis, you'll have the pH. On the y-axis, you'll have the mass. Okay. What will happen is you will have the pH stay very, very, it will be plateau, it will be very level, and then it will shoot up very quickly, and then it will even off again. So it's got, this is called a sigmoid shape in maths. Okay. In order to find out the mass, and they won't do it as nicely as they did there where it was exactly 1.2 to give you a pH of 7, what you'll do is you'll find 7 on the x-axis, you do a dotted line across until you get to the curve, you'll draw a dotted line down like that, and therefore here, where the dotted line meets the x-axis, just there, that is the mass that neutralizes the acid.